This is a spectrogram, a visual representation of the various frequencies in a sound recording. Right now, it's showing an advanced AI model trying to transcribe a 20-second audio file. The model expects a predictable pattern, but the waveform breaks apart. The AI fails to process the sound, returning a low confidence score and a string of empty error boxes. Chen Sheng is the developer running this test. His job is building and refining regional dialect recognition AI for major tech companies. He spends his days fine-tuning acoustic parameters so that automated systems can accurately identify speech from across the country. In his professional world in Chengdu, human speech is something to be captured and categorized. It's an environment built on systemic order, where every sound is turned into clean, standardized data. But Chen is running a private experiment on his own time. He's feeding his model recordings he took on his phone at a hospital in Guizhou. The voice belongs to his grandmother, who is nearing the end of her life. He expects the system to transcribe her voice like any other dataset. Instead, the screen populates with hollow squares, blank, white bounding boxes where the words are supposed to be. To understand why the algorithm can't see what's right in front of it, we have to look past the code and into the history of the woman speaking. We can analyze her speech in linguistic layers. On the surface is the standardized Mandarin and common dialect she used for decades to ensure her grandson could understand her. This chart tracks the model's performance on that surface layer using a loss curve, a metric that shows the model's error rate during training. As the machine successfully maps her audio against millions of standardized data points, the curve follows a steady downward trajectory. But after she suffers a stroke, her speech pattern shifts. She begins to lose her grip on the standardized language of the city, regressing away from common dialect and back toward an older tongue. The AI's progress stops. The curve hits a wall and begins bouncing erratically. Within this cognitive drift, she speaks with a new urgency. She describes running away from her husband's family and begins reciting traditional crying marriage songs, ritual melodies she hadn't performed for most of her life. The training curve flatlines because the algorithm relies on uniformity. It needs to see a pattern repeated by thousands of different speakers to recognize it, and it has no way to process these deeply localized, non-standard vocal sounds. The machine reached the edge of its map. It requires a massive dataset to identify a single word, but here it is processing a language that is leaving the world along with the person speaking it. To find the origin of those unrecognized sounds, Chen Sheng travels to a remote mountain village in Guizhou following his grandmother's death. The village is defined by a different set of data: the sharp smell of wood smoke, the feel of cold mud on the path, and the ancient timber walls of the family home. During the funeral rites, a specific ritual must be observed. To guide the woman's soul, the family cannot use the name she went by in the city. They must call her by her true, original name. As the priest begins the ceremony, the family starts to chant. They repeat the same untranslatable syllables Chen heard in the hospital: Nant Sheng. This name is a piece of the disappearing culture of the Mao people. These spoken traditions are maintained by the older generations in the mountains, but they are rarely heard once the younger generation leaves for the city. Chen can hear the syllables, but for the algorithm, the context is missing. Without the history of the village and the specific purpose of the ritual, the audio remains nothing but noise to the machine. Chen Sheng returns to his apartment in Chengdu and sits back down at his workstation. He opens the file and looks at the row of empty boxes generated by the AI. He finally understands what those syllables mean. He knows her name, and he knows the history behind the songs she sang, but he realizes that her identity doesn't fit into the software's standardized categories. Instead of forcing a translation, he deletes the boxes and leaves the space blank. Software models use language taxonomy codes to organize global data, standardized identifiers like ZH-CN for Mandarin. These codes are designed to simplify and categorize human identity into a manageable system. In a quiet moment of technical defiance, Chen Sheng navigates to the language field in his model's properties. He types in a new code that the system doesn't recognize: Nant-xand. By creating this custom field, He's deciding that this part of her life should remain uncatalogued. He is choosing to protect a memory by keeping it out of the training data. Chen Sheng builds the systems that try to categorize the world, but he's choosing to leave this specific piece of it unmapped. Some histories stay alive through the personal act of remembering, even when the computer sees only a blank space.